Now we should be recording. Hello, everybody. So let's go to my slides. I think that's the hot button for getting it full size. OK, today we're going to talk about regular expression. And before I start, I will, let's have a few kind of apologies first. This one is sliding on its own, so I have no control of it. I'm a little bit of a geek, so I have kind of added all my lecture includes references to stuff that could be funny, at least to me. You don't need to laugh, but I at least is very entertained, so I can teach this course and do all of this stuff. So I have a little fun with that. Second, and more importantly, I talk fast, so I might be kind of skimming over part, and you might ask, like, hey, what the hell happened right now? So I'll try to kind of compensate for this by just repeating myself a lot. So I apologize for that. Second. And the third thing I'm going to apologize for, I'm going to throw you a little bit into the deep end. I'm going to start with the introduction with some examples. And the problem with kind of throwing yourself into examples, which is something that I recommend doing in a lot of different types of topics, regular expression is fairly ugly as a language. If you don't know the components of it, it just looks like gibberish. So I imagine for people here that has never seen regular expression, it's going to be a lot of gibberish for the first couple of slides, or 3 slides, or something like that. So I apologize for that. But don't worry, if you just kind of bear with me through the different slides as we go forward. We're going to go through everything in detail, and as I said, I'll repeat myself, so you will not miss a thing, even though you don't understand all the details of what's going on in the first few slides. OK, so all my slides are written as scripts, which we can run. I've added comments to them to understand what's going on. So what are we trying to do? We are trying to do simple substitution. This is something that, given all the training you have in Python at this point, should be fairly easy. You take some text and you replace text with something else. All students deserve to pass the course in 3331, and I want to replace pass with fail. So I do a replace, pass with fail, very simple. And now, instead of doing this with slides, I'm going to do this in my terminal. So give me 2 seconds, and we're going to switch format. There we go, V star. And I apologize for the selection of editors, but this is my editor of choice. And here we are back at the slide of the introduction. We're going forward, and we're back at the slide where we can run the code. So this is basic Python code. And again, my geekiness, doing this through scripts. Hey, I run Python, run b1 replace, and it says all students deserve to fail the course in 3331, as we expected. Nothing kind of complicated with that. So, but let's do it a little more complicated. Let's say that we want to replace a word. Let's say we want to replace the word apple in the text that we have in the source text there. But apple might pop up somewhere else. For example, at the end of the text, you see the word pineapple. So apple is part of the text, but we only want to replace the part where apple is a unique word. And when we try to replace apple with orange, which is the typical thing we do, we get this. The target word is orange, but to make it hard, I will now throw in a pine orange, which makes absolutely no sense. So clearly, it's not doing its job. There we go. Going to the next slide. So this is where we kind of throw ourselves into regular expression. In Python, regular expression is evoked by a module called RE for regular expression. We have the same source text, but instead of doing substitution with a replace or any type of other modules that you have in Python, there are probably about 10 ways of doing text replacement. With regular expression, you use the command sub, and then you do what you want to look for, what you want to replace it with, and the text you want to replace it with as an on. So fairly simple, straightforward, though the commands in what I do around apple is not the part that you should be focusing on right now. But as you can see, when we run the code, it works as expected. The target word is orange, but pineapple stays pineapple. And that's the cue here. We're doing search of text, we're doing replacement of text, but we're doing it in a way that allows us to be smart about how we do it. So making sure that we don't get any false positives or false negatives, in the sense that we're trying to find something and we're grabbing too much or grabbing too little compared to what we're actually trying to find. Right. Let's make it a little more complicated. Data extraction. So you haven't talked about this, and I'm not sure how many people are familiar with it, but we have something called logging. And when you do debugging, when you're very happy doing your print statement all over your program, in professional programming, we don't do that. We use something called a logging module. So when a project reaches a certain size, always use logging, and there's a lot of logging type of tools. There's one specific one for Python, and typically it creates strings that looks kind of like this. It says something about this kind of severity of the logging. Obviously, you can adjust this for however you like, and a message that says what has just happened. So write code for assignment int 3331, too lazy to document code, submit code to GitHub, assignment failed. And let's try to pick up all the lines that are errors. So if you're going to do this in a normal situation, then obviously you're going to just loop over each line, check, hey, does my line start with an error, and print that line out. So very straightforward. The only line that gets printed out is the error line. Now, the example that the counter example I'm going to show you is completely ridiculous. It's never going to happen, but hey, why not? Error. The logging messages might be in a more complicated format. That's one thing. And secondly, they might be multi-line. So just trying to grab something that starts with an error might not capture everything. So in this really, really dumb example that might never, ever happen, error happens on the beginning of a line, but it's part of a continuation of the line above. So the sentence is, try not to expect the word error at the beginning of the line. Look what I did. Make it difficult. So then kind of two problems arises here. One is that you can't just look for the word error. And also you can't do error colon, because now there is a date stamp and a module reference saying where did the debugging happen. And secondly, you can't do iteration line by line, simply because an error message might now kind of be split over multiple lines. So you need to grab kind of the next line character, the new line character as well. Obviously you can do that, but you can't do the iteration style that we're doing, have done so far. And as expected, this will fail. It grabs 3 lines, everything that starts with error. But it's not what we want. It's not separating that error is done over 2 lines, because it's separating them into 2 distinct lines. And the last error is correctly grabbed, but still, there's something that we might want to try to address in a proper way that grabs it correctly. So how would you do that? We do some regular expression. Now the regular expression is getting really messy. So please, as I said, I apologize. We're throwing you into the deep end. You're not supposed to understand it yet. But you see the search string? That is our regular expression language. You have a question? Yes, I asked about that. Yes, there we go. Better. As I said, regular expression is really, really ugly. It's about as ugly as it gets. Why it's ugly? It's because it tries to be compact. So every command, everything you do is usually reduced to about 1 character, if it can. Sometimes 2, never above 3, which means that, you have to do a lot of special characters to get everything, what you try to intend, into your code. Anyway, if you run the code, it grabs exactly what we want to do. I added an extra character as a new line here, simply to make the distinction between what's a line and what is the new line between the logging messages and what's a new line inside the error message. So thereby, the 2 first error messages are grouped together, and a double new line before we get to the second error message. So it grabbed it correctly. Cool. So should we learn a little bit of this? Well, before we get there, a little bit of a digression. So when you guys are going to learn this, there is no better way of learning it than learning by doing. Now, for the assignments, you will be using the RE module, obviously, because that's kind of what the assignment is. But if you're going to learn doing it yourself by hand, playing around with RE module might be a good way of doing it. But learning to do things, I would actually recommend that you kind of consult your nearest text editor. So for those who haven't guessed it yet, or kind of have no experience with it, the text editor that I'm using on the screen is called Vim, and I will never, ever, ever recommend anybody using Vim unless they're very, very interested. And then it's like, maybe. But the nice thing about Vim and Atom and Emacs and PyCharm is that they have built-in regular expression support. So when you guys are playing around with this stuff, you can play around with regular expression straight from the search command, depending on how you do it from the different editors. I actually don't know how to do it in Atom, Emacs, PyCharm, but I know how to do it in Vim. But it shouldn't be that hard to find out, A, if the editor you're using right now supports it, and B, if you're going to switch to some of the others, how to do it. If you're going to have my recommendation, take a look at PyCharm. PyCharm is a fantastic IDE. A lot of people, my coworkers are using it simply because it covers what you need and it's specified for Python, though not open source for those who care about that. But for this lecture, I'm going to use Vim. And one of the reasons why I'm going to use Vim is A, I'm running code, as you've seen. And secondly, I'm going to use the regular expression commands in Vim directly. And they are done in a kind of annoying little way because it's the language for doing it in Vim is about as ugly as you do it in regular expression. So I apologize for that as well. But if you see down in the left corner, that's where I kind of insert my command. And when I say /\v, obviously because it needs to be 3 characters, I really annoy that, I can do search with regular expression. Right. So for example, we have this little thing. And then I say Control R, and then I run that command. So basically, I just copied the line that is on the bottom, feed it into my command, and it made a substitution. Yeah, some smiled. That's nice. Anyway, we're going to learn all about it. Everything that's in that last line is also, again, depend. We're going to get to it. So let's start from scratch. In regular expression, letters and numbers are themselves. That means if you're searching for the letter S, you will find the letter S. If you're looking for the letter P, you will find the letter P by pressing P. So spammy eggs and eggy spam replace spam with eggs. And we use the RE sub module. Again, sub is short for substitution. You're going to learn to love it. Part of this exercise. Listen, yeah. And we also have the findall, which is also a command I really like, which is basically search your document, search for all instances of a regular expression, and return it to me as a list, which you can iterate over or do whatever you want with. Run the code. Spammy eggs and eggy spam. We replace spam with egg, and we get eggs me's eggs and eggy eggs. Also, we search for the word spam in the original text, not the replaced one, and we get the word spam and spam. That's not that useful in the sense when you're searching for literal text. When you do find all, hey, we found the word we were searching for. What a surprise. And moreover, we have 2 copies of it, and it's exactly the same. So it's not really interesting at this point, but when we're going to do a little more complicated searches, it becomes obvious why returning the searches actually makes a lot of sense. So, this is my little thing, though. Anytime kind of your computer asks you, please press the any keys. Have anybody been in that situation? It might be from the era of the 90s, so it might be a little before your time, but it used to happen a lot. So I kind of named the period in regular expression, the any key. I think that if you try to search up the names of the different keys, it actually just referred to as matches any character but new line. That's the official name of it. I don't think they gave it a name. I call it just the any key because it matches whatever you want it to match, except for one thing, and that's new line, but we're going to get to that. So we have this search string, sing, sang, sung, song, sang. Let's go down to that line. Oh, right. And I can do my search. And if I say sing, obviously it's going to match sing. If I say sang, it's going to match sang. So we don't have any surprises here. But if I replace the A with a dot, which means any key, you see what happened? It matches the S and the I. And if I say NG, it matches the first word. And if I go to the next word and do the same thing, it matches that word. And it matches that word, and so on. So basically what I did is that I said that, you know what? I want a word that starts with an S. I want it to start with an NG. But it has a letter in the middle there, but I don't really know what that character should be. So I let it be open for the program to figure that out. So when you kind of send a regular expression with a dot, then it kind of indicates the regular expression. Now find anything that's a wildcard-wise, any character in that spot for one character. So if we run that code, with find all, it returns a list, sing, sang, sung, song, and sang. So now it starts to become obvious why returning all the kind of trace elements, as in all the matches, back to you might be interesting. The matches might not be the same in regular expression. Simply put, is that when you do advanced type of commands and insert special characters, then matches might vary. So here's an example of that, clearly. Okay. That's the first element that you need to know. The second through, what will it be, the 9th is this one. So as I said, there are one character, there might be two, at the worst it's 3. So if you want to match a word character, you say /w. So slash here is the command type of character that invokes that the next character after it should be interpreted as a special character. And you can read the W as what I like to call a word character. And if you capitalize it, it becomes the inverted of it. So anything but a word character. The /d is a digit, /large D is not a digit, and so on and so forth. So if I kind of go down here and I say search for, and I have to do the V, and then I say the W, but hey, I want to do 2 W's. See, it skipped over the A because A has only one character, and I wanted to search for a string that contained 2 word characters after each other. Or if I like, I can search for a digit like that, and it jumps straight to the first digit it finds. Very straightforward. Cool, right? And obviously, you can do the opposite. I said, I want to match a non-word character. See that we're beginning of line 7. I add a large W, and it matches a string. Wait a minute. Oh, right, that's where I was. So it matched the first string. So if I, for example, am here, it should match the string, the space between after the word, simply because word characters matches, well, the alphabet. It also matches numbers, just so you know. They're not mutually exclusive, so you kind of keep in mind that having this slide, which obviously you can download from the webpage after this lecture, is really nice to have. You're not expected to remember every single command that comes with it, but you should be able to kind of look at the table. What is the command? Okay, if I have that list, or you have that list, you should be able to grab the right one and write the correct regular expression to do your search. and match the correct words that you're looking for. Okay? The last two lines, the new lines and the tabular, are in a sense overlapping what I like to call like C-style kind of interpolation command characters. I don't know what to call them, which is something that you're used to in Python. They mean literally new line and they mean literally tabular. Now keep in mind that if you wrote any script in Python and put in /n or /t, then they will be kind of accepted as literal character, new line, and tab character. But keep in mind that we don't want that. We want actually the literal kind of interpretation of a slash and an n. And if you're going to go to the next slide, well, wait a minute, we're in search mode, like that. You can show an example of that. So when you use the slash command, you want to be able to cancel out that slash command. Simply put, when you say /n, you mean the character slash and the character n. Now, you could do this manually by doing //. In any language that uses slash as a command, // is always cancellation. But your regular expression might be a little more ugly to read, so I really highly recommend it that you tell Python that, hey, the string that I'm giving you should have an R in front of it. An R is a short term and it means raw text. That means that any text that you put into the string should be handled as a literal. That means slashes are slash, which means that when I feed rdd, or the r/d/d code on the line 10 there, the slashes here are literal. So let's see what happens if I removed it, for example, and ran the code. And it matches. Actually, it matches quite fine. The reason for that is that the D is not recognized as the command character. So it kind of figured out that, right, you don't actually use real command characters. So that was actually a really bad example. But as a rule of thumb, always remember to include your R. So in this example, we're doing the simple kind of task of trying to match time, which is always on the format of 2 digits, followed by a colon, followed by 2 digits. And digits, as we saw on the last slide, represent numbers by /d. So doing /d/d, colon /d/d should match all the clocks. And as we saw in this example, that's what it matches. It grabs all the timestamps straight out and give it back to you as a list, which is really nice for times when you're trying to search for kind of these type of things, which is kind of trying to find examples for these type of things. We'll get back to it. I have a couple examples, but probably next week. So, R prefixes. They are a little bit of an annoyance, but you kind of need to learn them off the bat because you're going to be using them a lot. Trying to remember when to use what. Try to remember, did I remember to an R? Should I have an R? Sometimes you should, sometimes you should not. But for the regular expression term, as a safe bet, always put an R in front of it. It's a good policy to do. Simply put, then you don't have to think about it. So text that you're going to search on should not, but text that you're going to search with, the regular expression terms, should always have an R. Now, we are allowed to construct our own character classes. Now, if you remember 2 slides ago, these character classes was actually on the slides. I used them as a way of kind of exemplifying what the /d and the /w were. They actually are commands in regular expression as well. So if you start with a bracket and end with a bracket, anything inside of it will be recognized as a single character that follows the rules of what you put into it. Now, the simplest way of using it is just adding a set of letters. So if I say /ABC, that means that I'm trying to match the letter A, or the letter B, or the letter C. Let's see if we can do that. The same thing. Let me search for A, B, or C. It matches A. You search again. matches A. Let's see here. It matches the character C. Does that make sense? Now, that's the simplest way of doing kind of character search. You can also do negative search, which means that if you put a hat as the first character in your character class, that means that I want to match everything except the following characters. So in this case, if we do the same command, but instead do this, then it will match the next character, and the next character, and the next character, and you get to the U, and it skips the C, as expected. Because we're going to match one character, and it cannot be a C, as you see down on the left side there. We have 319 of these characters. You can also do full ranges, which means that if you start with a letter and you end with a letter, you can do most of the alphabet off the bat. That's really nice if you say, hey, A through Z, that's kind of a given in the sense that you do a /W or something like that. But if you need to be more specific about it, obviously you can use character ranges. But if you're going to do something in hexadecimal, for example, like, hey, I want to match hexadecimal numbers, then you need to match A, B, C, D, E, and F. Then, hey, why not just make the range A through F in one command? That's what the dash means from line 10 and 11. And it matches it's case sensitive, which means that you have to specify if it's lowercase or uppercase. But beyond that, it should be very straightforward. And you can do the same thing with digits. Yep. Let's see this in practice. Partial case insensitive search. So here we have a string that contains 4 words, all of them hello. I want to pick up all the kind of words that says hello, but I don't really care about the casing of the first letter, but I do care that all the casing after first letter should be lowercase. So we can have hello with a small h or a hello with a large h. So basically the type of hellos that are legal in the English language without any type of literally major kind of frowning upon why did you write that. Because, you know, in Python, you write constants all caps, which is an insult to the language in some weird world. Anyway, we can do that. /V at the bottom of the screen. And if I say hello, it skips the first word, as expected. But if I do a command character and say, I want an H or a large H, and say hello, then, hey, I matched the first one, and moreover, I matched the second one as well, and the third one, and we did not match the fourth one. It loops, so it goes back. So the only 3 it matches is this, this, and this. Make sense? So that's kind of really, actually, the bracket version, except for trying to match hexadecimal numbers. That's what I usually use it for case-insensitive searches. Kind of very simple thing you do. Though, if you're going to do this with Python, there is actually a flag for it. You can tell it to be case insensitive. We'll get back to that, though. So, as you understood, though that A, B, and C through Z, O, and numbers are themselves, some of the characters are not. They are a command that tells that, hey, we're going to do something. And this is a list of all those commands. You're not expected to remember it, but it's nice to have when you're going to start working on your example. And if this is going to be relevant for an exam at the end of the semester, I don't know, you guys have exam these days? No, no exams, so you don't really need to deal with it at that point. Anyway, then you know that these commands have a meaning. So if you put in, for example, a $, then you should expect it, because you have that list. You can take that with you home when you do the assignments. Then you know that, hey, why didn't I match the literal $? Because it's a command. It actually has some meaning. So, to get the actual literal $, you have to cancel it. And canceling is done with a slash. It's not very surprising. So, hat, start bracket, dot, $, start curly brackets, star, and so on and so forth. All of them require a slash in front of it to be able to search it directly. We can exemplify this and say, hey, I want to turn on my regular expression, and then I say search for $, and it matches something completely different. But if I put a slash in front of it, look at that. It matched my $. I got the money. Cool. Which was my target. Now, a little bit of an extra rule, which is why I threw it up on there. Remember the character classes, the things that are put into the bracket. Obviously, anything inside the bracket is referred to as a command. And A might be an A in the sense of it's a character class A, but obviously, if you write ABC, you're not going to match the literal string ABC. It's going to match A or B or C, which means that, in a sense, the commands works a little bit different. So we have 3 special characters in the character class, which is the hat. You remember? That means negation. That means that instead of trying to match A, B, and C, if that's your character class, you want to match everything except A, B, C. And that's a special character. Thereby, it needs to be cancelled. Dash means range. So if you say A dash Z, that means any character from A and to Z. Therefore, that must be cancelled. And obviously, and this is very obvious, should be obvious at least, end bracket is obviously a character that is a command, because that means your character class is done. So if you're going to use that character, you need to cancel it. That's all the 3 letters that you can cancel. Now, keep in mind, there are, off the bat, there are 10 different varieties of regex at least. There are dialects. All of the different variety of regular expression kind of includes the same core principles and the same core commands. But beyond that, there might be some differences here and there. Some commands might be added. Some commands be kind of taken apart. And if you try to do, for example, a dash inside of a character class command, and it's not in between something, for example, put that at the end or at the beginning, then from your mind, that's not arranged because it doesn't have an upper bound. Now, the question, how is that interpreted? Do this kind of corner cases type of thing? And that really depends on your regular expression motor. And I actually don't know how the Python version works. So try to be unambiguous in your code, in a sense, that like you could try to hit the corner cases and get something that works, but it might not work on other systems, and it'd be harder for a person reading your code to understand what was going on. So if you're going to use the dash, please cancel it. Then everybody knows, like, all right, he's trying to match the literal character dash inside a character class. Right, moving on. Line starts with a hat anchor. Well, beginning of line anchor, that's usually what I call it. So that means that you take a line and you want your words to be connected to the beginning of that line. So remember all the way at the beginning, and we tried to match the error. And when you did it without regular expression, or we did it without regular expression, then we said begin with, it starts with, I think it was the Python command for it. Doing that in regular expression is obviously possible as well. You just start your line with a hat. Now, if you put a hat in the middle of your line, you're going to have a problem, simply because it will never be able to match anything. But at the beginning of the line, it makes sense. So in this case, we have our search text, which is Apple 1, Apple 2, and Apple 3. And we want to search for the text Apple space and then a digit, as we remember. /D means any digit. It's kind of nice that at least that letter corresponds to the English word that it's trying to match. So you can think of them as, what do you call them, mnemonics? Mnemonics? I can't remember that word. Anyway, so we want to match the first word. We run the command. And hey, we matched Apple 1. We did not match Apple 2, and we did not match Apple 3. Running the command in Python. Anyway, I use that all the time. That's kind of a command that's really nice to have. Obviously, you have more special characters. Now, I keep this separated from the commands that you learned so far because, in a sense, it's not really a character. You will never find the beginning of line character, though strictly speaking, you do have an end of line character if you're in C, but in Python you do not. It's hidden, or it's somewhere there deep into the kind of the core of what a string represents. But for the most part, string is represented not with the start of the line character. It's not represented with the end of the line character. And it definitely doesn't have word boundaries. So remember the example that we talked about all the way in the beginning, looking for apples, but not for pineapples. Now, back then, you just looked at the line. It's like, OK, this is something I need to learn, but I didn't really understand it. At this point, things should make a little more sense. So the target word is apple. We don't want to hit pineapple. So from the last slide, whoop, I might have clicked the wrong button here. Yes, I did. I might have commented stuff out. There we go. /b is a boundary of a word. That means that at that place, between the character that you place it, should be a space on one side and a word character on the side. It depends on what you define as a boundary character, but as a rule of thumb, word character versus non-word character is kind of what you should be thinking about when you see the /b. You can also specify which side the boundary should be, the left boundary and the right boundary with a kind of do an HTML tag style. So basically, if you write an HTML and send it to regex, that means I want to match this word, and I want that word to not have anything either on the left or the right side. Now, you could do the same thing with the /b characters. Obviously, it will match the same thing simply because you put word characters in between them. But it's nice to have the options. So going back to the apples and the pineapples. You see on line 14, R, remember the R, it means literals. It's a good thing to do. Now, B actually has a meaning in C style type of interpolation. It means back character. So if I didn't have the R character there, we would have a problem. And now I can actually test it out. And see, you see there? Even color highlights. And it's like, it understands /b. It's trouble. So if I run it now, it actually doesn't match anything. So we try to substitute apple for oranges. The target word is apple, but it's hard, so we'll throw in a pineapple. It did nothing. So if you get that kind of situation there, and you might be able to get to that situation during your assignment, it might because you forgot to add your R. So you save, and then we run again. And here you go. Target word is orange, but to make it hard, we'll throw in a pineapple. And it did exactly what we wanted to do. Apple is identified as a whole word in the first line, in line 8, while on line 10, it has a prefix, the pine, which means that the left boundary, the /b that I put on kind of before the apple on line 14 there, says that, hey, the word should start with apple. It shouldn't have any words to prefix it. Thereby, it did not match the pineapple, and we get the result that we want. Cool. So far, so good. I think this is a good time as any to take a little bit of a break, and I will see you guys back in 15 minutes. Control, and then I stop.